Now, it's my pleasure to pass the mic, and actually, it's my pleasure to pass the mic over to our first speaker, Sebastien. So, Sebastien, when you're ready, you may begin.
So thank you, Sonia, for this kind introduction. So it's my pleasure to be today the first speaker on this webinar. The idea is really to be able to present to you those humanized mice models, what they can do for you in the context of IO. Next slide.
And it looks like we have our first poll question. Sebastien, would you like me to go ahead and launch it?
Yes, please, thanks.
Okay, all right, everyone. I'm now going to launch our first poll question, and this is done in real time, so your participation is strongly encouraged and very much appreciated. So you see there, you have a couple of questions, or actually one question and a couple of options, and it's all about you. What is your business category? Is it pharma, biotech, public institute, or other? So please go ahead and cast your votes. I'll give you a few seconds to complete this simple poll question, and then I'll close the polls and we'll get right back to Sebastien. Perfect. That looks like it's the majority of our audience members. Sebastien, I'm now going to close the polls and let's take a look at the results. Okay, so here are the results of our first poll question. In the audience, we have 37% that said pharma, and then another 37% said biotech, while 21% said public institute, and 5% said other. So thank you, everyone, for participating in our first poll question. Now back to Sebastien. There you go, Sebastien.
Thanks a lot. It's good to know that we have people from all these different communities, biotech, pharma, academic. We have solutions for all these three business, I would say. So let's discuss about the science and the humanized mice model. So what is a humanized mice model? It's an immunodeficient animal with 3 mutations, not SCID IL-2 receptor gamma mutation. Those mice do not have any B, T, and NK cells from mouse origin and are very good recipients for engrafting with hematopoietic stem cells. So those CD34 positive cells isolated from cord blood are engrafted into those immunodeficient animals. Then we let the system maturate for 14 weeks, and we end up with a mouse that has fully developed a complete human immune systems from the dendritic cells to the macrophages, including B, T, human NK cells. All these cells are there and are fully functional. So that's really one of the biggest difference compared to PBMC engrafted animals, where at the end, we only left with T cells in the model. Here you have a full reconstitution of all these human cells of interest. Next slide. So on the next slide, you can really see how we humanize those animals. The first steps consist of a chemoablation. We use busulfan as a chemoablative agent to make room in the bone marrow. The advantage of chemoablation versus radiation is that step do not induce anemia in these animals. So the health, the robustness of this animal is preserved. The second advantage of our model is that we only use high purity CD34, meaning that those CD34 positive cells are not contaminated with CD4 or CD8 T cells that could induce over the time into these animals a GVHD reaction. The third advantage is that we produce those mice in advance, so you don't have to wait 14 weeks to start your study. We produce around 800 to 1,000 animals just to cope with the demands. All these animals are fully QC by flow cytometry and characterized for the main immune cells population. Next slide. As you are maybe aware, one limitation of working with humanized mice was the poor differentiation of myeloid dendritic cells and or NK cells. Those cells are there in humanized mice, but without an additional boost, the percentage of these cells is still weak. So what we have developed and optimized here at TransCure is a way of getting more of these cells in the systems, but without affecting the health or the translatability of the system. For example, the T cells that could get overactivated if you boost too much